Jai Hind. Today's lecture topic is algorithms and flowchart. So I am Dr. Aditya Pratap Singh, Associate Professor, IT Department. We are going to discuss various problem solving techniques and how these algorithms and flowcharts can be utilized in those problem solving techniques which can be implemented on a computer system. So let's try to understand what is exactly what problem is. So whenever I'm saying a problem that can be, we are discussing the problems which can be solved using computer. Computer is basically a tool that can be used to implement a plan for solving a problem. So this plan is basically implemented in the form of computer programs, and these computer programs are set of instructions for the computer system and which describes the steps that a computer must follow to implement the plan which we have created. So the creation of this solution plan is a creative process. It is an act of defining a problem. Until unless we have not defined a problem very efficiently and in an optimized manner, the ultimate solution for that problem will not be fruitful. So we need to identify what exactly the problem is. So next thing is like determining the cause of the problem. Why this problem has arrived, what the client is, what the problem is trying to stop doing something, or what a client is not able to do something. So for that purpose, what is the cause of the problem? Next thing is identifying and prioritizing. There may be n number of solutions available for a problem. So which solution is best? Sometimes the best solution cannot be implemented in our system due to some constraints. So what kind of solution we need to select or we need to prioritize? Then next thing is when the problem is defined and a solution, we are in process of finding a solution. So there may be popular two approaches for this problem solving. One is top-down design and another is bottom-up design. In the top-down design, we work in a divide and conquer manner. This approach of problem solving breaks the problem into small parts and solve each part individually. These parts in turn can again be broken into more smaller parts until unless we reach to a point where we can directly implement this. And later when all these parts or subparts are implemented, then we can assemble these solutions, these parts into a larger solution. This technique is also known as top-down design or modular development. So this is a very popular term which was become popular with the rulings of Britishers. They worked on this divide and conquer method for ruling a country like India. So here the same philosophy can be used for breaking this problem into small pieces and finding the solutions or implementing the solution for the smallest part which can not be broken further into smaller parts. So this strategy we can follow in computer programming also. First we start with a clear statement of the problem statement. That's why I already told you that the problem statement needs to be defined very efficiently. So we start with a clear problem statement, and we take this problem statement as a big idea, a single big idea, which is going to solve one of our problem. And this problem definition, we can try to divide this problem definition into smaller parts. So we will break it down into smaller parts like this. The big idea will be divided into part 1, part 2, part 3. We have divided this big idea into 3 parts: part 1, part 2 and part 3. These parts should be in a manner that each part can be solved individually and are not dependent on another part. So they should be unique or independent parts. If there is a possibility, like if we can again break them into smaller parts, then we can do this. So we will break these parts into smaller, even some parts, like part 2 is further broken into part 2.A, part 2.B and part 2.C. So this is how, like for example, if I take a system, if I want to make a library management system, for example, if we take, and the big idea is library management system, then we need to divide it into different sections, like management of reading section in library, reference section in library, and issue return section in library. Another thing which we can have, procurement management system in the library. So one system is divided into different parts. And again, like here part 2 is divided into 2.A, 2.B and 2.C. We can divide the problem into further subparts. Like these parts may be, like in the issue section, we have issue part and return part. So we have divided it into two. And another is fine. If there is a fine, then that is a different entity. So like here part 3 is divided into 3.A and 3.B. So this will work on like 2.B.1, 2.B.2, and the bottom nodes which represent the pieces that needs to be developed or which cannot be further divided into smaller subparts. So like here part 1 is itself a leaf node, and part 2.A is a leaf node, 2.C is a leaf node, 2.B.1, 2.B.2, 3.A, 3.B. These all parts need to be developed individually, and later on these parts will be combined to make a major solution. So this is how the top-down approach works. Next type of approach is bottom-up design. Bottom-up design, where we do not start with the big problem idea. Rather, we emphasize on the individual base elements of the system, like the previous example, library management system. So we do not start with the library management system. We start with the individual base elements like books, like student, like librarian. So we will take these base elements of the system first and describe them in a great detail. All their properties and all their functionalities or behavior is noted down, and these elements are then linked together to form a larger system. So then they are linked sometimes in many levels until a complete top level solution is formed. The best example for this bottom up design is object oriented programming, where the objects are the base elements and they are designed first and then linked with other objects to create their overall functionality or to finalize their behavior. In bottom up approach, the creativity is to find out the exact properties and functionalities which are the concerned properties and functionality for the system. They are need to be provided by the module. If a system needs to be built on over a existing system, then this kind of approach is more suitable rather than starting from scratch. It starts from some existing modules. So such kind of approach is followed in object oriented programming. Now let's start with next step in the problem solving phase, how we are going to design our solution. This is basically for top down approach. So first we can produce a journal algorithm. What we want to do, what is our solution? We can write that solution in the form of informal statements. So like the combination of these statements, what we are going to do are called pseudocode. So pseudocode is an artificial and informal language that helps programmers to develop algorithms, or we can say the previous part of algorithm is pseudocode. Pseudocode is very similar to everyday English. Like here in this example, if we want to find the average of a function, then we can write pseudocode like we are writing a function average, and we begin and we are writing read 5 marks. We are not specifying where we are storing, what are the variables for these. We are simply giving an instruction like read 5 marks. Then calculate the sum of 5 marks. We are not writing any formula how we are going to calculate, how we are dividing the result of step 4 by 5. So we are simply giving the instructions in the form of simple English. That kind of representation of the solution is called pseudocode. And if we talk about algorithm, then algorithm becomes a little more formal than the pseudocode. So pseudocode is a normal structured English that is used as an alternate method for planning some structured programs. There is no standard that is to be followed writing pseudocodes. They are simply, these are the instructions simply written in English language. Now come to algorithms. What are algorithms? So let's first understand what is the definition of algorithm, and let's start with that. So algorithm is a step-by-step method to solve a problem. Step by what we are going to do in each step that needs to be defined. And flowchart is what? The diagrammatic representation of algorithm is called flowchart. Sometimes the written text is not easy to understand, but the graphical representation of the same thing can easily be understood by the user. So this is the definition of algorithm. An algorithm is an ordered set of unambiguous executable steps that defines a terminating process. So each word is very important. Here I am writing an algorithm is an ordered set. Ordered set of instruction means every instruction has an order. Step 1 instruction, step 2 another instruction. The instruction at level 2 will not be executed after the instruction at level 3. It needs to be executed before instruction at level 3. So that is the meaning of ordered set. Which instruction is going to be executed at what time, in which order, that is already defined. Next important keyword is here unambiguous. Unambiguous means we will write an instruction which is easily understandable by the computer language or the compiler, where it can be easily executed. There should not be any confusion or vagueness. Like if I write A equal to A plus B is equal to C, So what is happening here? We are having A plus B and we are trying to store the content of C into A plus B. That is not clear. What we are going to do? Generally, what happens? The contents at the right hand side will be stored into the variable at left hand side, and right hand side expression will be evaluated to get a value. But here we are writing in a different way, which may confuse the compiler and can create some kind of error. Executable. Executable means the instruction which we are writing should be executable by the compiler, by the system. Like for example, we should not have a condition where like x equal to 10 and y equal to 0 and we are performing x divided by y. So such kind of instruction we should not write, because like in this example divide by 0 is occurring which is not defined yet. So we need always such instructions which can be executed. And a terminating process. At a point of time, the algorithm should be terminated. There should not be a situation where the algorithm is running indefinitely. So such kind of problem in the solution should not happen. Like in some, for a particular input, this solution is running. So that may not work. Either we should test our algorithm beforehand implementing that our algorithm is having a terminating state for each and every kind of input. These are the important properties which all algorithms must satisfy. Like every algorithm should have an input. 0 or more quantities are maybe externally supplied. Output, at least one quantity is produced in the solution, either in a data format or in a display format or something. Some kind of output should be there, whether it is being stored, whether it is being shown. Definiteness, that means each instruction is clear and unambiguous. Finiteness, algorithm must terminate after a finite number of steps. And effectiveness, that means it also must be feasible to have a desired output. Whatever user is trying to achieve, whatever client is trying to see, that kind of output should be the final output of this algorithm.